Right, we're live on air. Hello, everyone, and happy Friday. Today is April 3rd, and this is episode 11 of our Google Hangouts and podcast on all things DOCSIS. I'm Brady Volpe, founder of the Volpe firm and Nimble This. Let me introduce my guests today. We have more guests than normal. So we have the nefarious John Downey, consulting network engineer at Cisco Systems. John, how you doing?
Good, thanks. Glad to be back.
All right, John. We also have Brian Wilson. He's a security consultant and senior MSO solutions architect at Alcatel-Lucent. Brian's seen both sides of the world of hacking and hacking prevention for DOCSIS network. Brian, welcome.
Thank you.
And we have Dan Hagelin, senior software technical lead at Cisco Systems. He's been deeply involved in DOCSIS security at MIB and working on DOCSIS security best practices. Dan, welcome.
Hello, everyone.
So, guys, thanks for dropping in today. This hangout, we're going to be talking about DOCSIS, of course, but our focus today is on DOCSIS security, which is why I asked to have all of you on and a little more broad audience. A couple of key areas in DOCSIS security that we're going to be talking about. One of the more obvious ones is sort of hacking cable modems, theft of service, which obviously impacts cable operators because we have people on the DOCSIS network using DOCSIS traffic and not paying for it. So that's a very obvious one that people are familiar with. Another area that we want to talk about is denial of service attacks, also distributed denial of service attacks, DOS, DDoS. So the impacts that we have on this is it slows down CMTSs because we have excess traffics going both onto the CMTS and out of the CMTS. And so we have cable operators that, either we have this excess traffic, they can't access the CMTS, or they're getting complaints from ISPs saying, hey, you have this traffic going outside of the network, and so it's causing problems either directly or indirectly. And then the third topic that we want to discuss today are really targeted attacks on individuals that may be on the DOCSIS networks. We hear things like Sony having major issues and stuff like that, but we also want to look at, if there's a weak point in the network, that weak point may be the DOCSIS network. It could be somewhere else, but we want to look at how we can better secure the DOCSIS network, and really all of these tie together because we're really talking about securing the DOCSIS network, whether it's against theft of service or against someone who may be targeting a high-profile individual, trying to get information from that individual to use it against them in a really malicious way. And this could be someone in the U.S. doing that, or it could be a foreign nation state doing that. So kind of all these topics together we attack them in different ways. But the focus today is how can we make the CMTS more robust, make the DOCSIS network more robust, and kind of isolate some of these. So let's take the first topic first, which is kind of the one that I think we think about most often, which is theft of service. And so I'd like to throw it out there as a topic. What can we do to make the DOCSIS network more secure and prevent theft of service on the DOCSIS network? So John, you want to take a stab at that? You got some recommendations on how we can prevent theft of service?
There's a couple things that come to mind. From the very beginning, we used to have customers that would make their own CM files, silver, gold, bronze, whatever you want to call them, and they would put in, because the configurator for the cable modem was freeware. A lot of people would download it off of Cable Labs or maybe Cisco or someone else, whoever they got it from. They'd make themselves a CM file on their PC, then they would upload it from the PC into the modem. Well, TFTP was never really supposed to be allowed through the Ethernet port of the modem. The modem was supposed to TFTP through the coax cable from the CMTS or through the CMTS to the coax side of the modem. So we came up with ideas like TFTP Enforce, where on the CMTS we didn't allow modems to TFTP other than either through the CMTS or with the CMTS. So that kind of blocked that for a while. Then we had something called Dynamic Shared Secret, DMIC, Dynamic Message Integrity Check, and Dan can talk about that a little bit more. We evolved in the layers of security. So TFTP Enforce now is no longer really needed. DMIC is much more secure. And DOCSIS 3.0 also brought in, what is it called, EAE, Early Authentication Encryption. I think that's the proper
Yeah, it's EAE, early authentication encryption, which
So I
encrypts
mean,
everything before the cable modem registers with the CMTS.
correct. So we're also encrypting, modems doing the registration process, whereas before we were just basically encrypting the data further down, further in with BPI plus, things of that nature. And maybe Dan can kind of elaborate on some of this stuff. The other point I want to bring up was if you do, is this kind of go down another path. You know how I am, right? Go on a tangent. If I have modems I know that are clones, from the Cisco side, we have a feature called Cable Privacy Hot List, and we can block MAC addresses if we know that MAC address is a cloned modem or the wrong modem or a theft of service, whatever, and it blocks the modem from ranging. So a word of caution on that would be don't put a MAC address in that's supposed to be there because you'll never even see it in NID-R1. So you'll chase your tail trying to figure out why you can't see this MAC address ranging at all, but it might be because you purposely blocked it. And that was just another little feature we have many people might not know about called this hot list, where you can block specific MAC addresses from ranging on the CMTS. So to go back on DMIC and EAE, maybe Dan can elaborate a little bit on those two features.
Sure, Dan, go ahead. You wanna touch on some of these?
Sure, absolutely. So the end result is that you do not want the miscreant or the hackers to reuse CM configuration files. Anytime that you create CM configuration files with an external tool, you need to also configure that same password on the CMTS, and so that's why that's how the regular MIC and eMIC actually also works. So you create the CM configuration file externally. You use a passphrase like "Don't hack me," and then you configure "Don't hack me" as the secret password on the CMTS, which then is used to validate that the CM configuration file has not been modified. The weakness in that is that whenever something goes over the coax network, anybody can sniff that. Which means if you can sniff your neighbor's gold service and you're just paying for bronze, you can actually, as John mentioned, you can save it locally to your hard disk on your PC, and then the cable modem, as it boots up, as long as it's hacked, you can say, hey, use this local configuration file instead of using the one that's provided by the DOCSIS network, by the provider network. So DMIC fits into this where that cannot happen anymore because DMIC has a per subscriber password that is dynamically generated. So as soon as the cable modem does its initial ranging, a dynamic password is generated, and it's it's a garbled password that nobody knows. And then so when the CM configuration file is downloaded to the cable modem, it registers with it, and it's validated with that garbled one-time password. If you try to reuse that one again, even with the same modem, it'll fail. If somebody else attempts to register with it, it's definitely going to fail because it will not pass the MIC check for that other modem. Again, because the password is on a per modem, per registration basis. So DMIC solves a lot of problems that way. EAE is early authentication that happens right after the ranging process. What it does is it hides, it does the encryption, which means it hides the IP networking CM configuration file information. So it attempts to do something similar to that. It doesn't quite work with broadcast packets, and it's only DOCSIS 3.0 and newer modems. So it does not help with the more widely deployed modems, DOCSIS 1.1 and DOCSIS 2.0 modems.
Right, so if you have a DOCSIS 3.0 CMTS, you may not turn on EAE because you still have a lot of DOCSIS 2.0 modems out there. Is that correct?
Yes, although when you have EAE has different policies, and you can say, hey, one of the policies is everybody needs to run EAE, so it's total enforcement. But there's other policies too where you can say, hey, only if you are a DOCSIS 3.0 modem do you need to run EAE, or only if you tell me that you're capable of running EAE, you must run EAE. So That's so. There's different policies that you can configure based on your service group. If you have a service group that you know everyone's DOCSIS 3.0, I would say just force them to run EAE.
Right. But no, I think it's important that you mention that about the different service policies, because I know some cable operators are not using EAE because they say, well, I still have all these DOCSIS 2.0 modems out there. But knowing that we can still use it and at least add an extra layer of security for our DOCSIS 3 modems, and as the DOCSIS 3 modems continue to grow, we're adding that extra security policy on there. So, Brian, so we've talked about these additional security measures that we can put on there. Let's say as a cable operator we have put security measures on there. Does that still mean that we've absolutely made cable modems hack-proof, or are people still finding ways around hacking cable modems? What are you seeing sort of on the streets, so to speak?
Well, there's no way to ever secure anything completely. And as John and Dan were pointing out, the hot list is a great feature, especially if you identify a non-valid MAC address. You can put the hot list on all the devices that MAC address shouldn't be on. And then the EAE authentication, vendor-centric, you can actually set that where you have service groups, because DOCSIS is always backwards compatible. So you have to always support everything else. But there's a lot of great tools that come from the different vendors that allow you to kind of lock your network down better, but you're never 100% secure. And you always got to be vigilant and looking out for what's out there and keeping an eye on the network. I mean, there's, as we're going to get to eventually, is access lists, cable filters, and then what nobody wants to talk about, DPI. It is your best friend as long as you're not blocking traffic across the board, which would be fair share. But there's a lot of tools out there that are available for the service providers to protect the end customers and the internet in general.
Right. And so, I mean, one of the things that people talk about are perfect cloned modems. So we get the MAC address, we get the BPI plus key, and it's a perfect clone. So how do we prevent those?
Well, when you deal with the perfect clone scenario, a lot of MSOs kind of say that when you have a perfect clone, nobody's innocent. Because in most cases, not necessarily all cases, most cases you have to have physical access to the device to make a perfect clone. And I'll let the other two gentlemen step in if they need to help me out here, but you normally need to perfectly copy everything from the JTAG of the device that's valid to make a clone of it. So a lot of times you run into perfect clones. Some carriers or MSOs or service providers will block both, because at that point it's compromised. But there's always something new out there. And as providers, vendors, service providers, and any customers, we just got to keep our eyes and ears open to what do we do next to prevent this.
Right. Okay, thanks, guys. The second...
Oh, sorry.
Go ahead, John.
I think, Brian, you bring up a good point, because ultimately, in order for you to create a perfect clone of a cable modem, you need physical access to it. That's the only way you can get the public certificate and the private keys associated with the public certificate. So whenever you have a clone out there, it's either been sold on eBay or physical access has been achieved by some hacker to get to this information.
Exactly, I totally agree with you. There's only been one case that I've ever seen in my time in cable, and that was a loophole in a firmware that was beta to begin with, where a perfect clone was made for a remote download of JTAG. And I don't know a vendor out there that would risk that, CMTS side or modem side, because it's just, again, you almost always have to have physical access to make a perfect clone. And in that case, both parties are guilty. You just hot list it on every device you have.
So let me interrupt. So are you suggesting that maybe two friends got...
I think John Downey's data dropped for a second.
Yeah.
So yeah, I'm deciding either two friends have decided to try this, or somebody bought the modem secondhand and it just came online and started working. So if you don't buy your cable modem from your
But
ISP,
if my buddy is on a different CMTS and CMTSs are not aware of each other, then I could have the same exact MAC address on multiple CMTSs, right? Because the CMTSs don't really know what each other are doing. So are you sort of saying or suggesting that it could be like two friends talking to each other and say, hey, I'll pay for the gold, you pay for the bronze, we'll split the difference, I'll let you clone mine, and you'll be able to get faster speed? Is that possible? Could that be a scenario?
Well, in that case, only one's paying normally. But again, both parties are guilty at that point. So if I'm a service provider and I see two devices that are perfect, like certificates and all, I would personally block them both. Somebody's going to call in if they're paying for service.
How are you tracking the same MAC address? Just through DHCP or entire subscriber database?
That depends on the service provider. A lot of them. So I've been all around the industry. You know this.
Yeah, of course.
I've been with the MSO. I've been with the MSO management company, and I've been with multiple vendors. So I kind of get around, working boy. But at the end of the day, most of the major tier ones, or even some of the tier twos, they'll run a diff tool against MAC addresses known across CMTSs, or the provisioning system. Almost nobody runs an out-of-the-box provisioning system. Everybody wants to build their own tools to monitor, maintain. So whatever tool you're going to use, no matter if it's from a vendor or it's homebrewed, you should always verify your MAC addresses do not show up in multiple places. Once they do, that's when you should look a little further, and that's when your abuse department or whoever handles the security for the service provider should start digging into what's going on here and why am I providing data access to the same MAC address in two locations. And that's when you start trying to figure out what is your abuse policy.
Yeah, that's right. Your DHCP server basically will tell you behind which CMTS the cable modem resides. So if that cable modem keeps moving behind different CMTSs, that's a very good sign that the MAC address of that cable modem has been cloned, and the cable modem itself has been cloned and is moving around. One other thing is, and this is pretty much universal these days, but DOCSIS 1.0 modems it's easier to clone those because they actually don't have public certificates that chain to the DOCSIS root, which means they're very simple to clone. You can actually throw on any old public-private key on there, and they'll work. But if you have a DOCSIS 1.1 and newer modem, all of those certificates chain up to the root certificate on the CMTS given out by Cable Labs, and those certificates are married to the cable modem via MAC address. So there's actually an entry in the certificate itself that's the MAC address. And that's why I say to make a perfect clone of a DOCSIS 1.1, a newer modem, you need the physical access to grab all that information.
Definitely. I mean, and at the end of the day, you're probably blocking all your 1.0s. If not, it might be time to roll a truck if you have that for service issues. And we come back to it that it's X509. Even when you get into DPoE, that's getting to the point where it's going to be supported. So as an industry with the vendor side and the nonprofits, Cable Labs, SCTE, we're always looking ahead on how to better secure our networks, not just for theft of service, but for customer privacy. I mean, that's a big thing, and that's something that, as an industry, we all really do care about.
Okay, let's move into the next topic, guys, which is sort of denial of service and distributed denial of service. So I have clients that will have maybe attacks onto their network where they are unable to access their CMTS, or they'll have suddenly excessive amounts of traffic going across their DOCSIS network. Or the alternative is where they'll have a bunch of subscribers on their DOCSIS network that, unbeknownst to the subscriber, they'll have worms or other traffic that's generating unwanted traffic outbound through the CMTS and out to some other unknown victim, and they're getting bombarded by traffic from that subscriber's DOCSIS network. And so that subscriber or that cable operator maybe get notified that, hey, your public IP addresses are sending out this unwanted, undesirable traffic against some unintended victim. And they get notified and say you basically need to cease and desist sending out this traffic because the public IPs are owned by the cable operator. So kind of two different scenarios, but all related to different attacks that someone's setting up a virus or worm and they get onto host computers. So what's the best way of dealing with this traffic, minimizing it on the DOCSIS network or keeping it away altogether?
So let's quantify that a little bit. Denial of service is not just someone trying to do something bad. It might be someone trying to steal more service than what they're allowed to. Brian brought up a good point that, and we kind of frown on it, deep packet inspection. There's no problem with doing deep packet inspection as long as we don't act on it by being biased toward a certain traffic. So on the Cisco side, I see a lot of customers start looking at byte counting, STM, subscriber traffic management, where if I notice a customer has 50 megabit per second service, but I still have him sign a service level agreement that says you will not exceed 1 terabyte in 2 days time frame or a week time frame or whatever it happens to be. So when he hits that certain byte cap, maybe I can put him into a lower speed tier on the fly. The modem doesn't reset. It basically uses packet cable multimedia or whatever. And I can put him into a lower speed tier, or I can try to upsell him, push him to a walled garden website and say, hey, I noticed that you've been doing gaming and you're exceeding your byte count for a 2-day time frame. So maybe you want to upgrade for $5 a month, or just keep an eye on it. Or I just utilize it just to see who the heavy talkers are. Because we keep saying 10% of your users are using 85% of your bandwidth. So those are a couple of things as far as, knowing who your heavy hitters are, because that could be sort of denial of service, because our whole marketing and our whole business model is based on oversubscription. And that doesn't go very well if a couple of people are overutilizing. So I just wanted to hit that real quick. But you're talking more on the lines of maybe ARP storms. I say ping of death, but that's usually not a problem. But other hackers making the NIMDA, what was it, NIMDA, way back in the day, worms and Trojan horses. I know one of the things Dan can probably elaborate on is our ARP filters. That happened a long time ago where some people's home gateways, home routers were ARPing quite a bit, and it was causing an ARP storm on the CMTS. So we came up with ARP filters that we can filter some devices that are ARPing too often in too short of a time frame. We have that on. It might not be on by default, so customers turn it on, but then they quit looking at the show cable ARP filter commands to see who has been filtered. So there's one thing to have a feature on, but you still need to be proactive and look at it to see who's been filtered, because maybe those devices are correctly being filtered by the CMTS, but we need to figure out why they're being filtered, and maybe we need to, what would you call it, upgrade their firmware on the modem. Maybe it's just a firmware or a router upgrade. So Dan, you want to elaborate at all on any of that stuff?
Yeah, absolutely. So ARP filters, that is one way to limit the number of ARPs coming from the subscribers going up to the CMTS, basically. The other thing we have is DRL, what we call DRL. It's divert rate limit, which is somewhat of an engineering term, but that's what the feature is called. It basically separates out traffic from different subscribers. So you can say, hey, for every subscriber, you can only send up 4 packets per second, and anything above that is gonna get dropped. The nice thing about that is that it's on a per subscriber basis. So if one subscriber misbehaves, he's going to be limited severely, and it does not affect the performance of another subscriber. So everybody gets 4 packets per second. It's not in an aggregate of all the subscribers that you have. So ARP filters and this DRL, they work hand in hand in preventing attacks on the CMTS from the subscriber side. DRL also exists on the WAN side, where you can limit the amount of traffic that goes up to the CMTS as well. And in the newer boxes, actually, we have something called COP. That's in the CBR8, the one we just shipped, which is control plane policing, and it uses regular policies where you can specify packets per second, etc., going up to the CMTS. So there's a number of different ways that we can address these attacks.
Now, is DRL a replacement for ACLs? Or do we no longer need to put ACLs on the CMTS?
No, ACLs are actually for traffic going through the box, versus DRL is for traffic terminating on the box. So, and that's because when you launch a storm attack, Frequently they use, I mean, you can use unicast, at which point it goes through the box and you're attacking a specific destination. But frequently also it is broadcast, and because the CMTS is a router, it terminates on the router, and so you can prevent the router from being overwhelmed by enabling this DRL feature.
Okay, because one of the things I see is that oftentimes operators will not have ACLs, or they won't have a comprehensive ACL on the CMTS. And is that a best practice to put ACLs on, and maybe define what ACL is?
Yeah. So access control lists allow you to specify what traffic is and is not allowed to traverse your network. I've seen it deployed very frequently at MSOs, where you can say, hey, you know what, there's no SNMP traffic that is allowed to come from the internet to my subscribers. Of course, you need to keep the door open so that you can access the cable modems, the subscribers via SNMP, but you definitely want to block SNMP traffic from the outside probing your subscribers. And so an ACL is a good tool to prevent that from happening. So
and what you're saying is like whitelist the SNMP traffic that you want to send. Whitelist yourself versus trying to blacklist. Whitelisting is saying, okay, we want to approve SNMP traffic that's part of our network, versus what sometimes people try to do is blacklist IP addresses that they've seen harmful in the past. And I think blacklisting is always a difficult thing to do, because you always have IP addresses that are going to be continuously popping up, and that blacklist will get very, very, very long.
Yep, that's correct. That's right. And an alternative to this is, I think as Brian mentioned, or maybe it was John, that you can also use cable filters. Cable filters is very similar to ACLs, but it is applicable to device types. So if you want to apply it to an STB or an MTA, but you don't want to apply it to regular hosts, you can do that. You can specify all those in the cable filters.
Okay. Brian, did you want to add anything on that? Okay, I think he had to step away for a moment. So
hold on. Let me interject real quick. Let's we talk about all these things to help with theft of service, denial of service, hackers, cloning. How about, and Dan could probably elaborate on this because he and I kind of worked on it together, was the negative of, how do I want to say this, Dan? Mobility, CPE mobility. So we had this case, me and Dan did, where if you have a PC, say you're doing wireless, and you're in a hospitality environment, a hotel, and that hotel has multiple access points or wireless cable modems, and you walk around inside your hotel room from one side of the room to the other, and you end up jumping to a different cable modem. Now your CPE looks like it's part of a different MAC address. By default, in our CMTS, that would look like, how would you say that, Dan? A cloned modem, or just illegal CPE movement?
Yeah, it would be a hacked CPE basically. You're saying that the CPE, somebody basically cloned the CPE and put it behind a different cable modem. So the way the Cisco CMTS works is that it will probe the existing location, and it will take a while for that CPE to actually be allowed to move to the new access point, which is behind the new cable modem. But as John mentioned, we did we had done some work on this now, and you can specify which cable modems or which subnet is part of a mobility group, and at which point now the cable modems can freely move from behind different access points, basically.
Whether the CPE can move behind different cable modems, is that right? CPE
That's
mobility.
Correct. That's right. Yeah, the assumption
so
here that an access point is associated with a cable modem, and yeah, I should have probably started with that. So when you move behind a different AP, you're also moving behind a different cable modem at the same time.
Very good. And the other one was, this has come up before, if I put a modem in the hot list, does the CMTS block the modem from ranging, which I doubt it, or it just ignores it? So I suspect it kind of ignores it, so it never shows up in NIT R1. So the concern would be if you have a lot of modems in the hot list and they're ranging, and let's suppose for a hypothetical situation, the modem is off a 4 dB tap. Normally that modem would range with 35 dBmV and work properly. Now let's suppose it's in the hot list and it ranges 35, 38, 41, 44, 47, 3 dB increments. Goes all the way up to 60 dBmV. And it just keeps ranging and ranging and gets a new UCD and it ranges again, a new UCD and it ranges again, rescans downstream and just goes through that process over and over. Now obviously a customer might not leave it like that because they're not getting anywhere with it, but could that modem cause laser clipping? And that's kind of the concern. I mean, it's going to be quick, very fast, but if the modem normally transmits 35 and ranges to 60, that's 25 dB higher than all the rest of the modems. So the question would be, maybe Dan, you can sort of elaborate, but I believe we are just ignoring the ranging process, but the modem is still a modem. It is a generic modem that will range. That's what it does. Is that correct?
Yes, that's correct. We cannot prevent the modem from sending packets in the initial ranging opportunities. Now, because we do ignore the packets, the initial ranging packets, the cable modem will basically assume that, okay, you know, as you mentioned, it didn't hear me. Maybe I'll crank up the volume a little bit. And it'll keep doing that, and you know, just keep jumping from channel to channel, trying to connect up to the CMTS. Because the CMTS is, you know, has the MAC address in the hot list, the CMTS will simply drop those ranging messages. Because this, you know, you're putting MAC addresses in hot lists because there's a hacked cable modem on that network. The hacker is going to get frustrated and you know, we'll give up pretty soon on that one, simply because the whole objective of the hacker is to gain network access, and with this feature, there is no way that they can ever access the network.
And because our initial maintenance time slots are time aligned within a MAC domain, that modem ranging should never affect other modems' data, I would think. Correct?
That's correct. That's correct. No, yeah. So yeah, initial ranging opportunities are a different chunk time slot of data requests.
But he could, if there's enough modems in the hot list on the same upstream, eating up some mini slots of time, he could affect other good modems from registering, in theory.
That's when you get the.
Go ahead.
So that's when you get the PMI tool and you figure out where they're at.
Well, we definitely need to track them down. I agree. We definitely need to track these guys down.
Yeah, and something else to think about that I've noticed when I was on the MSO side is you can have home amps customers purchase that are failing that cause some of these issues with dB, you know, huge dB fluctuation changes. So your hot list may not always just be hackers. It could be noisy modems, but you've got to deal with them at some point.
That's a very good point. I never really thought about, you know, the old babbling set-top box, you know, babbling modem that's just ranging, is not listening to DOCSIS timing at all. You could put that in a hot list and just block it, right?
Definitely. Bad firmware. Say it's a really old Terion modem that got off eBay, and they plug into your plant, you got problems. Because those things can go up to 63 dB. They're loud.
Yeah. Very good.
Okay. So final topic for today, and this actually came up at the Cable Labs Winter Conference, is, you know, it's so far we've kind of been talking about hackers that are just out there for, you know, kind of fun and games, want to steal some service, but there's a different type of hacker, and that's the one that really wants to go after a specific individual or maybe a specific company, and they're kind of using the same techniques maybe as someone that would to steal service, but they're doing it for a very intentional purpose. And, you know, we think, well, you know, maybe this is just going to happen to a Sony Pictures or, you know, a large organization, but it could happen to, you know, any particular individual that someone wants to get information out. For example, it could happen to me. It could be someone who just has a grudge against me because they don't like these Google Hangouts. So now they want to go after my cable modem and start listening to see what email I have, try to get banking information, just try to go after that. What was so profound to me during this presentation at Cable Labs Winter Conference was that when someone gains access to someone's communication information, say they are able to make a perfect clone of my cable modem and just sit there and listen to the traffic going back and forth, they do this for a very extended period of time. The average that they see someone listening to a person's traffic was 200 days, and they've seen examples where people were doing this for over 2,000 days. So it's not like someone just breaks into the network for a couple days, gets a couple emails, and they're out of the network. It's really extended hacking that goes on. They get into the network, so they're really intent on getting in, and then once they get in, they're in for a very long time. So I think it's really important for our listeners to understand that security is very important, and if DOCSIS is a weak link into the network, someone's always going to get into the weakest link. But then once they're in, they're really in for a long time when they're going after a targeted individual, whether that's just someone like myself or a high executive within an organization to get information and go really deep in. So I'm interested in your thoughts on that, because so far we've been talking about what I think are more trivial levels for a cable operator, but if someone's interested in going after a high-level target, a high-level executive in an organization to get information, then they're going to work really hard to do that and continue to work to overcome some of the preventative measures that we've put in place.
Well, at the end of the day, if you're a high-value target, you should be using encryption to day one. But again, with TAC-X, AAA, at that point, you got to protect the core. If you've got great security measures in place already to locate duplicate MAC addresses in the network, which the vendors provide you many great tools to do that, but they don't own every piece of network infrastructure you have in your MSO. So a lot of MSOs do homebrewed tools that do diffs against MAC addresses. But again, you've got to protect yourself at multiple levels, and I know it's not favorable to say it, but DPI is your best friend when it comes to these things, as long as you're not blocking anything. It's a great view in the network. The MSOs are not looking at individuals' data. They're looking at trends in traffic. And why is extra issues happening at this one location versus another? But again, at the end of the day, I mean, if you think you're a possible target for a high-value hack, encryption, 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 tunnels, encryption, everything else. And then the midpoint is there's so many features in the different CMTSs. I've dealt with many of them. I've been with a couple of different vendors. Cisco's got some great stuff out there. I think Dan's one of the first guys that spoke out publicly and writing white papers on how to lock your equipment down, because a lot of cases people don't do stuff until they're told they have to. And we're telling you now, check your security policies. But to block, so if you're a dedicated attack client or vector, you really got to look at how do I encrypt my traffic, how do I protect myself, and then from the MSO side, what is going across my network? So there's a lot of different places you can prevent these things, and it all comes down to liability for the MSO and the end customer. What kind of risk are you willing to accept?
How do you do deep packet inspection of something that's encrypted? If it's already encrypted, I mean, what good does it do? Can it still do good?
Well, if you're already encrypting, then you're most likely protected. But those that don't encrypt, DPI is going to give us a little bit of insight of some of the things that happen, because DPI will look at duplicate MAC addresses depending on how it's set up. And there's many different vendors that make DPI solutions, and you can even build your own with open source.
Okay.
Yeah, and Brian, I just want to summarize. I think there's two key takeaways from what you said, Brian. Is first, there's an individual responsibility to me as an individual is to encrypt the things that I'm make sure that I'm using HTTPS when I'm transporting things, when I'm communicating with my bank, when I'm using email. So that's part of my responsibility as an individual. Make sure I'm encrypting myself using two-factor authentication. And then there's the cable operator has a responsibility to make sure that they're encrypting their network and using the best security practices on their network. So that's how we can protect both as an individual ourselves and a cable operator has that responsibility. I think those are the 2 points you were making.
Yeah, definitely. And most of the vendors out there that make hardware, they make all these great features and tools to protect both the MSO and the end subscriber, but it's MSO's responsibility to enable the tools.
Yeah.
Because there's always backwards compatibility issues, but at the end of the day, you've got to look at your risk analysis. Is this worth the potential risk that the customer or the network is facing?
Okay. So Brian or Dan, Brian said you have some papers and stuff on this type of stuff. Can you fill us in on that? What do you have? Where can we get this information?
Well, it's somewhat Cisco proprietary, as in marketing does not want us to distribute it.
Okay.
It's best practices for Cisco customers how to configure your device to run at maximum security. You know, from my view out into the MSO world, there are some MSOs that are very good about this, and some that are running wide open. So, to Brian's point of DPI, that is always great. BPI, the encryption of BPI, which is AES or triple DES, is only on the coax network. It terminates on the CMTS, which means that DPI is actually very useful going northbound, going towards the internet from the CMTS. However, if you are an individual that really cares about privacy, you would actually do encryption of your traffic on top of that encryption. So it would be doubly encrypted on the DOCSIS network and then singly encrypted upstream towards the WAN and the internet.
So it's funny. What's funny about that is I think Brian might have been saying DPI, Deep Packet Inspection, and now you're bringing up BPI, which is Baseline Privacy. What does the I stand for anyway?
Interface.
Yeah,
interface.
There you go.
Yeah, BPI Plus every time. Don't do BPI. BPI Plus X509 certificates. And again, as Dan put it out there, not everything he's released is open to the wide internet. But I mean, most of your networks that are DOCSIS have Cisco devices. Pay your contracts and get access to CCF.
There you go.
So you actually bring up a good point. Also, that BPI Plus, there's a feature called BPI Plus policy, and in my opinion, you should always, if you know that you have DOCSIS 1.1 modems and newer, you always run with BPI Plus policy total, which means every single cable modem on your network is required to run BPI Plus and not just BPI. I think not having that is probably your biggest security hole.
I definitely agree with you. And again, BPI Plus and Force total, once you have that enabled, depending on the vendor flavor, because we've got to be vendor-centric to a certain extent, that's going to prevent 99% of your clones. Only perfect clones at that point pretty much can get through.
It's a great recommendation, and I completely concur with that. So, okay. Any closing comments from you guys on security in general and recommendations for cable operators?
I got one. Pay your contracts, whoever your vendor is. Stay up to date on your firmware, your iOSs, software releases, both modem and router side, because the threatscape's always changing. And as long as you're able to download the latest software that's from a certified release vendor that can pass your MD5 checksum, you're going to be in a much better boat than otherwise.
Yeah, I think we have to look at what's going on in the world around us when we see major breaks going on all the time. Home Depot, Sony, Target, everyone getting impacted by security threats. We have to realize that same thing is happening. If we don't know it's happening in our cable networks, it's likely going to happen in our cable networks if it hasn't happened to us yet. So I mean, like what Brian is saying, keep everything up to date, implement more security practices. If we're not doing it now, there's no better time like the present to start implementing security policies in our network.
Let me give you one more theft of service thought, and that would be, I'm going to give you a hypothetical again. I have DST, DOCSIS Set-Top Gateway. I order the latest pay-per-view event, Ultimate Fighting, whatever, UFC. Ronda Rousey is fighting that night. So I order the fighting pay-per-view. Then I take that set-top box, and I go to my local bar. I plug it in. It's on the same fiber node. I plug it in, and now I sell $5 a head. So I'm buying that as a residential, but I'm selling it as a commercial. So how do we stop someone from doing something like that? one of the ideas I saw kicked around and looking at is not knowing the exact distance based on time offset of the modem, but knowing that the modem moved and what the time offset was when it normally was operating, and the fact that it went offline, maybe in the flap list. I have an insertion in the flap list. I noticed the modem went offline online, and now the time offset has moved by 100 ticks. Knowing that, I can estimate the distance it moved away. So there's a potential to maybe flag certain set-top boxes or devices that seem to be moving, and then maybe I notice that device also just bought a pay-per-view event. So there's a case where theft of service, right? It's a theft of service. You're doing something with the device that you didn't pay for, not what it was intended for.
Good point, John. And I think that could augment my income. Actually, I have a nice big living room
with a big TV, 4K TV.
That's right.
Well, I mean, the flip side is that's kind of like a feature for PMI maybe, where we look at the known offsets over a period of time versus a change. But we also got to be careful that we're not dealing with, again, amp issues, drop issues, because there's a lot of RF characteristics out there that can change over time, and sometimes dramatically in a short period of time.
Yes, I know. You and I, Brian, even talked about a potential patent on that, right? About the time offset movement and maybe tracking devices. And I think this would be multiple things. We saw the modem, multiple flags. It could be the time offset changed, the levels changed, it flapped in the flap list, but that modem also did just order a pay-per-view event. That's an extra flag.
Be careful, John. We still have a year left on that patent pending state.
All right, gentlemen. Well, I think we've covered the topic quite a bit today. I want to thank you each very much for your time. John, Dan, Brian, thank you very much. And we'll call it a wrap.
So, very good.
All right.
Thanks, guys.
Thanks, everyone, for joining, and enjoy the contents. And if you have any follow-up questions, please feel free to submit them, and we'll catch you on the next Hangout. Bye, all.
See ya.
Bye.